through the definition first. A circle is a locus of a point P which always moves at a constant distance from a fixed point. Okay, I have underlined two terms over here, constant distance and a fixed point. Okay, so let's see this thing geometrically. What's happening here is we have a fixed point over here. Okay, and we have a point P which is moving such that it is at a constant distance. Let's say this distance is something fixed distance from this fixed point. Okay, its distance is always this much only. Okay, so we can say that its locus becomes a circle. Right? So this figure gives us a circle. And this constant distance is known as we all know, this is known as the radius. And we can denote it by R. And the fixed point is called the center of the circle. So this is the center of the circle, and usually we denote it by O or C. Okay. So locus of a point P which always moves at a constant distance from a fixed point, and the fixed point is called the center and the constant distance is called the radius. Or we can say that the path traced by a moving point such that its distance from a fixed point remains constant. Okay. This is the moving point, it's moving something like that, such that its distance from a fixed point is always constant and that distance is always equal to R. Right? So this is a constant distance and this will be the fixed point. So this was the definition of circle. And let's see this thing mathematically. What will be the general equation of the circle? And if we say to find the locus of this circle, let's say the distance, this point, the moving point is denoted by x comma y. The abscissa is x and the ordinate is y. And this center is h comma k. Now can we apply the distance formula over here? Yes, we can. This h and this k we already know because we know the center of the circle. But this x comma y is not known. We want to find all the values of x comma y which satisfy this condition. Okay. So we can apply the distance formula and we can say that this is, let's say, P, and OP will be equal to under root x minus h whole square plus y minus k whole square. Okay. And we also know that this distance is constant and this is equal to R. OP is also equal to R. So we can say that if we try to equate these two equations, okay, the equation which we'll get is x minus h whole square plus y minus k whole square is equal to R square. So this is the general equation of a circle. How did we get square over here? If we square both sides, we will get OP square is equal to, we'll get rid of this square root and this will become R square. So this is the general equation of a circle. So all the values of x and y which satisfy this equation will lie on this circle. Okay, all the values of x and y which satisfy this equation will lie on this circle. On this circle, and by on this circle I mean on this path. On this circle doesn't mean that it can lie here or here. On this circle means that it has to lie somewhere over here only. This will mean inside the circle and this will mean outside the circle, which I'll discuss later. What's that? Now, if you try to see this equation, this is a second degree equation, right? And if we try to open the terms by a minus b whole square, which will give us a square plus b square minus 2ab, we'll get a x square term, okay, and we'll get a y square term. We'll get a x square and a y square term always, okay. What else will we get? We'll get a x term, okay. From here you can see that this will become minus 2hx. So we'll get a term where the degree of x is just 1. So we'll get a term with x and we'll get a term with y, and then we'll get a constant term. Let's say the constant term comes out to be c, right? The constant term comes out to be c. Now, what we always do is, we always write the general equation of this circle as x square plus y square plus 2gx and plus 2fy plus c is equal to 0, right? So if we expand this equation, we'll get all these terms, all these 5 terms. First term will be x square, then y square, then the terms which are having x and which are having y, and a constant term in the end, right? So we always write the general equation in this form. So this is the form, this is the very basic form when the center and the radius are known. if you know the center and the radius, you can simply apply this equation and you will get the equation of the circle, right? And this is a general equation of circle, general second degree equation of a circle. The equation of the circle will always be of second degree. As we saw that equation of a line was always of first degree. First degree equation in two variables, like 3x plus 2y is equal to 5. This was the general equation of a line, and this will be the general equation of a circle. Understood? So, now the basic doubt which everybody gets here is that why did we use 2g over here? Why didn't we use g or 4g or 8g? Why did we use 2g while we could have used gx and fy? Right? So this is the most common doubt everybody gets. So the reason is that if we try to complete the whole square, here, by completing the whole square, what do I mean? I'll show you. If I try to club all the terms with x over here, plus 2gx, plus y square, plus 2fy. Okay, and this value is equal to minus c, as you see. If I try to complete these whole squares, I need a factor of 2 always. Why do I need a factor of 2? Because in the identity of a square plus b square plus 2ab, in the identity of a plus b whole square, which we have to apply if we need to complete the whole square, we always get a term of 2ab. That's why I'm writing 2gx over here. That's the reason we are not writing gx, neither we are writing gx nor we are writing fy. We are writing 2gx and 2fy. Okay. Now if we try to complete the whole square over here, this equation will become something like this. This will be, now I have to add g square over here. If I add g square, this will become x plus g whole square. And I have to add f square over here. Right? And if I'm adding g square and f square over here, I'll have to do the same at RHS. So I'll get this. Right? And this will become x plus g whole square plus y plus f whole square is equal to g square plus f square minus c. Right? And if I try to compare it with the equation where I knew the center and the radius of the circle, this will become something like this, that x minus g whole square plus y minus f whole square is equal to under root g square plus f square minus c whole square. Right? So now I know that the center of this circle, whose general equation is given by x square plus y square plus 2gx plus 2fy plus c is equal to 0, is given by minus g comma minus f. So the center of this circle is always minus g comma minus f. And if you see, right, this was the point, this was the fixed point over here. If this is x comma y, the fixed point over here is minus g comma minus f. Because we are seeing the distance, we're calculating the distance of this x comma y from minus g comma minus f, and this distance is coming out to be under root g square plus f square minus c. Because it's becoming this whole square. Right? So by applying the distance formula, we'll get this term. And so we can say that the radius, the fixed distance is coming out to be under root g square plus f square minus c. Right? So this is a very basic concept of circles, that if you're given a general equation of second degree, how to find the center and the radius of the circle. So let's take an example. You're given that x square plus y square plus 4x minus 6y plus 2 is equal to 0. This is the equation. First of all, we have to recognize that this is the equation of a circle. How will we do that? We know we have a x square term, we have a y square term, we have a x term, y term, and a constant term. So this always denotes the equation of a circle. Right? And now I have to find the center and the radius of the circle. So how will I find the center? We can compare this by 2gx. So if this term is 2gx, the center of this circle, the abscissa of the center of the circle will be minus g. So we can say that 2g is equal to 4. So g is equal to 2. So the center of the circle will be minus 2 comma, let's find the ordinate. We know the value of 2fy. So 2f is equal to minus 6. We can say that f is equal to minus 3, so the center will be equal to 3. Because the center is always given by minus g, comma minus f. Right? So the value of g is 2 and the value of f is minus 3. Now I have to find the radius, and the radius will become under root g square plus f square minus c. So g square is equal to, g square will come out to be 4 and f square will be 9. So this will become 13 minus 2 is equal to root 11. So now I know the center of the circle, minus 2 comma minus 3, and the radius of the circle, which is given by under root 11. So that's how we calculate the center and the radius of a second degree equation circle. Right? Now there is a term which comes. Now let's assume in this equation x square plus y square plus 2gx plus 2fy plus c is equal to 0. I get such values of g, f and c that g square plus f square minus c comes out to be 0. Now if this thing comes out to be 0, now we know that the radius of this circle will be equal to 0. Okay, the radius of this circle will come out to be 0. And the second condition can be g square plus f square minus c is negative. Okay, the basic condition is g square plus f square minus c is greater than 0. So these are the three cases which can have right here. Now see, the radius of the circle is given by under root g square plus f square minus c. Now for a real value of radius, the term inside the square root should always be positive. The term inside the square root should always be positive. Therefore, this value has to be positive always if I have to see a real circle. So this is the basic condition of a real circle, that g square plus f square minus c is always greater than 0. If this value is less than 0, let's first see if this value is less than 0, this will denote imaginary circle. Imaginary or no circle. Okay, so this is a condition when a circle does not exist, right? Because we cannot get a square root, negative number of a square. And if this value comes out to be 0, we know that radius is equal to 0. This thing is called a point circle. This thing is called a point circle. So point circle is just denoted by a dot. So this is a dot, this is a point circle with the radius is equal to 0. We just know the point. We just know that this is a point. So what will be the equation of a point circle? Let's see. If I want to construct a point circle at this point, let's say 2, 3. So the point circle will be x minus 2 whole square plus y minus 3 whole square. We know that these two will come because this is the center, 2, 3 is the center. And we know that if it is a point circle, its radius will come out to be 0. So I will equate it to 0. So this will be the equation of a point circle. Now we know that if sum of two squares is 0, then individually both values will be equal to 0. So x is equal to 2 and y is equal to 3. So on this circle only one point will lie.